A material to be analyzed which is not present in a well-ordered form is examined by spectroscopic techniques. That X-ray spectroscopy can measure also the spatial structure of materials resolved to atomic levels is owed to a method employing synchrotron radiation, X-ray absorption spectroscopy. Its successful application is due to the enormous intensity and the tunability of the wavelength of that radiation. A small group of specialists make use of so-called EXAFS spectroscopy, which stands for Extended X-ray Absorption Fine Structure, when they want to determine distances between atoms and the number of atoms. Information of this kind is very much in demand, as for instance a catalyst may become inactive as a result of even minute changes in interatomic distance, or conversely allow conversion into a desired product. The spectra also show the oxidation state in which atoms happen to be at that moment. Whether a metal remains immobile on a landfill site or may be washed out by biological processes depends on its oxidation state. In 2000, a movie based on a true story created a worldwide stir, Erin Brockovich. An assistant, played by Julia Roberts, together with a lawyer, sued a public utility because of a series of initially unexplained cancer cases. In that story, a difference in solubility of the two levels of oxidation of chromium played a decisive role. The biologically inactive chromium-3 deposited can be converted into soluble chromium-6 by biological or chemical processes and, as a consequence, poison the groundwater and give rise to severe diseases. Chemists nowadays use the fine structure characteristics of the X-ray spectrum for soil classification by comparing toxicity levels and, in this way, avert health hazards. Each oxidation state gives rise to a characteristic fingerprint in the spectrum. The light required for examination is filtered out of the white spectrum of synchrotron radiation by means of a monochromator. Detectors used to determine light intensity measure the power absorbed by the specimen under study. A measurement consists of several hundreds of data points, each of them with a slightly different wavelength, and contains the absorption edge, including the fine structure near it, for the respective element to be examined. This method can be used efficiently only with synchrotron radiation sources, as the X-ray source must have a white, very intense spectrum. ANCA allows all elements to be examined from sulfur to heavy uranium. X-ray absorption spectroscopy is used to characterize nanocrystalline and amorphous materials for the production of new functional materials. Heterogeneous catalysts are such functional materials, for they consist of very fine metal particles applied to a carrier material. If the effectiveness or stability of a catalyst is to be improved by analytical techniques, this requires information about the electronic and geometric structures of the metal particles. The stability of rubber contained in car tires is influenced decisively by the bonding conditions of sulfur. The electronic state of sulfur and the type of atomic neighborhood can be determined precisely by X-ray absorption spectroscopy.